Hi S3, it's Mr. Bull here again, and I'm going to be going through questions 3 to 6 on the S3 exam revision, and these are the written questions and not the multiple choice questions. So let's get stuck into how to answer question 3. So question 3 says a hospital radiographer calculates the equivalent dose of radiation absorbed by a patient. This is done by multiplying the absorbed dose by a radiation weighting factor. So first question, state what is meant by radiation weighting factor. So for this one, what we're going to be saying is that the radiation weighting factor, or also known as WR, that's a short way of writing it, is a measure of the biological effect of that radiation. Okay, that's what it is. All right, WR is a measure of the biological effect of that radiation. Now, that is just a definition you should know from your booklets, and that hopefully you will remember for any tests or exams that involve radiation. Right, question B says that during a scan of the patient's brain, the absorbed dose is measured as 1.5 milligrays. The mass of the brain is 1.4 kilograms. Calculate the energy absorbed by the brain during the scan. So, if you were to look at your equation booklet, you would see that D equals E over M. Now, if we did a triangle, because E is on the top of the fraction, it goes on the top of the triangle. And you've got D, and you've got M. Now, we want to find E, we want to find the energy. So if I put my thumb over E, it's actually going to be E equals D M. All right? And it says that the absorbed dose is 1.5 milligrays. Now, milli is times 10 to the negative 3. And we're timesing that by 1.4 kilograms. And remember, we keep it in kilograms, not grams. So if we do that, we find out the answer is 2.1 times 10 to the negative 3 joules. And that's your answer. Okay, now for C is a half-life question, and it says in another medical procedure a radioactive chemical is injected into a patient. The chemical is prepared by the technician from a source which has an activity of 320 megabecquerels. The source has a half-life of 6 hours. Calculate the activity of the source 18 hours later. So first of all, the thing that we want to do here is we want to find out how many half-lives are in 18 hours. So, if one half-life is 6 hours, we could just do 18 divided by 6 gives us 3 half-lives. Nice and easy. 3 half-lives. Right, that's the first little bit. Now, we need to start from at 320 megabecquerels, and we need to work our way down until we've had 3 half-lives. Now, we're going to keep it in mega, because we don't really care about the units in this little section as long as we make sure we answer with megabecquerels at the end. So let's have a look. 320, and this is the nice easy part. 320, divide that by 2. You get 160. That's one half-life. Divide it by 2 again. That's the second half-life. We get 80. Divide that again. We get 40. So our answer will be 18 hours later equals 40, and remembering those units now, megabecquerels. All right, there we go. Perfect. Right, so that's the answers to question 3. Let's go on to question 4, and let me just move this down. Here we go. Brilliant. And question 4 on here. So for question 4, let's turn the page. It says, a lighthouse uses a converging lens to produce a beam of light. The lamp is placed at a focal point of the lens. Copy and complete the diagram to show the path of the light rays after they pass through the lens. Right, so let's move this into the correct position. There we go. So for this one, we're just going to draw, for 40, we're just going to draw the lens again. Okay, and what's seen on the diagram there. So you've got the rays of light coming through like that, and you've got your lens like that. That looks good. With arrows coming through here. Now, when you come from a focal point and you go through a convex lens, it actually just moves parallel after it goes through. Now, the one in the middle will always go parallel to the other ones on the outside, but it should look like something like that, and we put the wee arrows here just to make sure we're doing everything correctly. And that's what it should be, okay? Now, that would be slightly different if it was a concave lens, but it's asking us for a convex lens, so that's the right answer. Right, B says, the lamp flashes once every 7.5 seconds. What is the name given to the type? What is the name given to the time between each flash? Time between each flash, i.e. time between each wave, and the time between each wave is also known as the period. Okay, so that's asking, it's almost giving you a wee definition, and you have to figure out what the answer is. So it's actually period. Okay. C says the lighthouse also uses a foghorn to alert ships. A ship is at a distance of 2.04 kilometers from the lighthouse. And what's it asking? It's asking, calculate the time taken for the sound to reach the ship. Okay, so to do this one here, calculate the time. It looks like a simple distance equals speed times time equation. Rearrange that using our triangle. Remember, D's at the top, V and T. Cover up the T. You get distance divided by speed. So, distance here, remember 2.04 kilometers. So let's just do 2.04 kilometers. That's times 10 to the power of 3. So, even could write it like that. But easier than that, I could just then put that in a calculator, but it would be 1, 2, 3, would actually be 2,040 meters. So I'm going to put that in here to make it nice and easy. Divided by the speed, and remember it's speed of light, or no, speed of sound, sorry, not light. Speed of sound, which is in your data booklet, and you should see that for speed of sound in air, it's 340 meters per second. And that ends up getting 6 seconds. Okay, so 6 seconds. That's your answer. All right. And then the last question is D. And for D, it says light waves are transverse waves. Sound waves are longitudinal waves. Describe each type of wave in terms of its vibrations. Right, this is the one that you always have to know when you're doing an exam. Okay? And so transverse is vibrations at right angles. Okay, at right angles. And we should also add to wave direction. Okay. Oh, can I fit that in? Oh, I think I can. And then longitudinal, okay, is vibrations are parallel to wave direction. All right, so the difference is right angles for transverse and parallel to longitudinal. Know those definitions, please.